Hello students, this is solving exponential or log equations. I I feel like this video will not be too long. It'll be a short video because we have already learned how to exponentiate logs or apply logs on both sides to convert to exponential. So we don't have to actually switch x and y. That's the important thing that you have to note. Usually, solving involves just one variable or not. In any case, you don't have to switch anything. You just convert between exponential and logarithms. That's what I was trying to emphasize. I'll just you do maybe three or four problems, not more than that, in this video. But I'm going to give you a complete key for this handout for your perusal in my Google Classroom. Okay. All right. So if you look at the situation here, I'm just checking if the video is continuing. So you just have to exponent. It's already an exponent. You have to apply log on both sides. No switching. The base is the same as the base of the exponent. So everything else is just the same. Okay. So this will become x equals log 5 base 3. I want to see you all avoid this step. I don't say avoid, but the thing is, this should be more intuitive. You don't have to necessarily write this particular step all the time. So this should be more intuitive, okay? So even if you don't write, I will not take away points. I just want to emphasize that. So I want you to be in a position where you directly jump into this step. All right, so I'll skip few problems. Let's look at something like this. So subtract the 5 first, because we have to isolate this exponent. That's why. So this will be 3 times 7 to the 2x plus 5 equals 1029. But please do not ever multiply 3 and 7. They are not to be multiplied. 7 is the base of this exponent, and 3 is the y-intercept or the initial value, as you will see later in the word problems. But never ever try to multiply them, okay? We need to actually do the opposite. Divide 3 on both sides. All right. So you'll be just left with 7 to the 2x plus 5 equals 300, I think 343, right? So see, from here on, you can do this in two ways. You can actually write this as 7 cubed and this as 7 to the 2x plus 5. And you'll say the bases are same, so we can equate the exponents. And you can go with the exponent rules. Fine. You will definitely arrive at the correct answer. So since exponential and logs are inverses to each other, either way is fine. Since we are actually using the conversions here, I'm going to do it the log way. Okay, so this will be log 7 to the 2x plus 5 base 7 equals log 343 base 7, and this is gone, right? And as I was telling you earlier, 7 to the power of 3 is 343. Log evaluates to an exponent. And yeah, you just arrive at the same thing. Yeah, for sure. So 2x, I'm going to continue here. 2x equals negative 2. Okay. So x is negative 1. The only catch here is we have to just substitute it back into this to verify if this is a reasonable solution or extraneous. I will leave that to you. I'll do that in my key though. Okay. All right. So I want you to focus on the seventh question here. Here there is he's asking you to solve for p, meaning p is in the exponent. To find the exponent, we definitely have to convert this into log. So this is where the logarithm plays an important role. Okay, so um, what you need to do here is first get rid of the 16, right? So you're not switching between n and p, mind you. So this is 1.41 to the power of p. Now we are applying log on both sides. And what is the base? 1.41. That's right. So log 1.41 to the power of p base 1.41. Since both bases are same, p will come down, and this is log n over 16 base 1.41. Okay, that's the idea. All right, this is the solving. Okay, so this is a familiar thing that you will see if you are taking pre-AP chemistry also. Definitely in not too long, not too far away, you will learn the log. What is that? The acid and bases, the pH scale. So this is the hydrogen ion concentration. That's how they write it, and we need to convert this into an exponential function to actually find the hydrogen ions, the number of hydrogen ions. Okay, so same thing. So we have to exponentiate it. So what is the base here? The base is a common log. So the base is 10. So 10 to the power of pH. pH is a single entity. Okay, don't think it is separate. That's how they write the pH scale to determine the law, whether a certain solution is solution or a material or whatever that is, the chemistry term is an acid or base. But I forgot to do something. We need to first get rid of the negative, which I did not do. Oops. So we have to divide by -1 first. So this becomes negative pH equals log H plus, right? Now the base is 10, so we are going to exponentiate the log. And this is the hydrogen ion concentration. That's it, just a single step, right? That's it. So this is how this goes. I don't want to continue anymore. I'll give out the key, but I would encourage you to do the handout by all by yourself and then check my key. All right. See you. Bye bye.